Hey everyone, welcome to Transformations Day 3, where we're going to wrap it all up and really get comfortable with going forwards and backwards. I would like to start off today with two bell work problems, as it were, here, and these are just for graphing, to see if we're comfortable with our reference graphs and how to do the transformations. Here's the first one, y equals 1/4 cube root 2x plus 1 plus 3/4. Okay, and that's a cube root there. 1/4 cube root of 2x plus 1 plus 3/4. Will you please graph that? Why don't you pause your video, give it a go for graphing, and come back after you've tried it. Okay, welcome back. I'm going to write down the reference points. -1, -1, 0, 0, 1, 1. I recognize two x transformations and two y transformations. I know the y transformations are done with PEMDAS, so I'm going to multiply the y's by 1/4 and then add 3/4 to the y's. And these two x transformations, inside is opposite land, so I'm going to follow SADMEP, which means I'm going to subtract 1 from the x's and divide the x's by 2. So let's start that process. I'm going to subtract 1 from all the x's, and I'm going to multiply the y's by 1/4. So my new points will be -2, -1/4, -1, 0, and 0, 1/4. That's half the transformations done, but I have to come back and do the second x transformation and the second y transformation. I see times 2, which means I need to divide everything by 2. Or not everything, but all the x's. And I see plus 3/4, so I know I need to add 3/4 to all the y values. And so my final points that I'll be graphing will be -1. -1/4 plus 3/4 is 2/4, or 1/2. -1/2, 3/4, and 0, 1. So I'm going to plot those points, though I didn't give myself a lot of space for it. I'm going to plot those points, 0, 1, -1/2, 3/4, and that has to go a little higher. So does that. And then this is -1, 1/2. And then don't forget to draw in that characteristic shape. Okay, remember you have to label the points on the graph. It's not sufficient that they're over here. Please show me your work on how you're getting those points. I'll need that as well. And don't forget to be thinking, because I clearly wasn't thinking. This is cube root, Mr. Kukla. You got the right reference points, but that ain't a cube root graph. Yep, you're completely right. So don't make that really common pre-cal student mistake about drawing the wrong shape in, right? We need the cube root shape here, which looks like this. Okay, that's what we're looking for the correct shape. Okay, so there's the first problem. And here's your second one to try. Y equals -2 x over 3 minus 4 cubed plus 5. All right, so I'd like you to please graph this one using your reference function with its reference points and applying these transformations to it. Okay, pause the video, come back when you're done or you need help, and I'll go over it. So I'm starting with the reference points, which are -1, -1, 0, 0, 1, 1. I see two y transformations. I know I need to multiply the y's by -2. And what's that going to do to the function? this is going to flip the graph upside down. So instead of looking like this, I'm expecting some shape that looks like this. Okay? This shifts the graph up 5, but I'm going to multiply all the y's by -2 before I add 5 to the y's. Inside, I see 2 more transformations. These are x transformations. I follow SADMEP here, which means I need to shift the graph right 4 and then horizontally stretch the graph by a factor of 3. So I'm going to add 4 to the x's and then multiply the x's by 3. So let's get on with that. Plus 4 to all the x's and multiplying the y's by -2. So my new points, or my intermediate points, will be 3, 2, 4, 0, 5, -2. Now I'll come back and do that second round of transformations. Here I see dividing by 3, which means I need to multiply the x's by 3. And here I see plus 5, and since that's a y transformation, I do what I see. I add 5 to all the y's. So the points I'm actually going to graph are 9, 7, 12, 5, 15, 3. Nine, 7, 12, 5, 15, 3. Now, notice I drew in the shape first, and I like doing that a lot, but I'm really comfortable with my reference graph shapes and thinking about the transformations when I do it. Other students like to draw themselves some sort of coordinate plane, but then you find yourself doing this kind of thing. And I don't really want to go out to 15. So maybe this is 3, 6, 9, 12. No, I don't like that. That's not going to be very good. So yeah, I feel kind of stuck here. 2, 3, 4, 5, 6, 7, 8, 9, 10. See? I don't have more board over here. I don't want to do 2's. I guess I could do 2's, but then none of my points lie on any of these. So it feels very uncomfortable. 14, 16. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. And we want 9, 7. Definitely labeling the point on the graph. 12, 5. And 15, 3. And so what I'd say about this is it's going to help me if I actually plot these points. It might actually help me think about the shape. I'm not going to be able to draw this shape through these points. I have to draw this. But look, that doesn't look like a smooth curve. I would much rather see the smooth curve labeled appropriately. When I try and force it to this hand-drawn axes, it rarely works in a way that I feel good and comfortable with. Okay, so yes, we'll be doing transformation graphs of functions all year. And if you're moving on to Calc, you'll do them there too. So you really, really, really need to get comfortable with transformational graphing. All right. Next, I thought we could practice going backwards a little more, where I give you the graph with some points labeled on it, and I ask you to write the equation for it. So here's the first one I've got. This point is -5, -3. This point is -6. Oops. That's -1. This is -3. And over here, 4, negative 3. Or negative 4, negative 3. Okay, so according to the last video, when I see problems like this, I'm not going to run away. Instead, I'm going to, 1, decide what family of curves. Okay? Hey, by the way, uh, I'm making an assumption that you're taking notes on these videos and not just watching them. Because when we think about what you would do in class, many of you would take notes and then use those notes to do your homework or use those notes to study for tests. So yeah, I think you still need to take notes. So yeah, I'd be taking notes, which is why I'm writing this out. Decide what family of curves. Well, is this a square root function? No. Is it absolute value? No. What family of curves is this? Well, this is a parabola. So we know its reference graph is y equals x squared. So then 2, use the general form with your reference function. So my general form is going to be y equals ax minus c squared plus d, according to what we did in the last video. Though later on this fall, we'll be switching these to h and k, and they're going to represent our vertex. Okay. Next we said plug in the 0 point for h and k. And what I mean by 0 point is when I think about this parabola, this general y equals x squared, it's got these reference points on it, and one of them is 0, 0. That's my 0 point. I see some transformations have happened to this reference graph. It now looks like this, upside down, and there's the 0 point. So I know this had to move left 5 to get to there, and this had to move down 1 to get to there. So I'm going to replace in y equals x minus h squared plus k, I'm going to replace the h with minus or minus 5. Let's use a different color for that. Minus 5 squared plus, and what's our k value? Our k value is this, minus 1. And many students like to tidy this up. They like to say y equals ax plus 5 squared, and then plus negative 1 I could just write as minus 1. We're not quite done yet. We still need to solve for this a value, and we said in the last video we would pick one of these other points. We've already used this point, so we can't use it again. But we could use one of these points to help us solve for a. So step 4, plug in another point for x and y to find a. Okay, so what's that going to look like for us? I'll plug in negative 3 equals a, negative 4 plus 5 squared minus 1. So now I need to solve this equation. I know negative 4 plus 5 is 1, and 1 squared is 1. So I have negative 3 equals a times 1 minus 1. Now, I can't subtract these because this has an a and this doesn't have an a. So don't try and do that. Instead, add 1 to both sides. So I get negative 2 equals a. So I can put this all together now for the equation y equals negative 2 x plus 5 squared minus 1. There's the equation for that parabola. Okay? So now that we've reviewed how to do this, let's try some more, or let's have you try some more. How about we'll start with this one. Okay, I want 2, 2. I want 0, 6. And I want 4, 6. These are the points on our graph. 2, 2. 0, 6. 4, 6. So please write the equation for that parabola. Pause the video, come back when you're done or when you have questions, and we'll see what we can do. Okay. Hey, welcome back. So I think this belongs to the parabola family like the last one. So I'm going to start off with this. I know I'm supposed to take the 0 point and plug that in for h and k. There's h, there's k. So now my equation looks like a x minus 2 squared plus 2. And this makes sense to me. I've shifted the 0 point, which used to be the vertex at the origin, right 2 and up 2. This says right 2 and up 2. And then finally, I'm going to plug in one of these ordered pairs. I'm going to use 0, 6. And I'm going to solve for a. When I subtract 2 from both sides, I get this, and so I know that a equals 1. Don't forget, you still need to write out the whole equation. We've only found the parts. We've got 1, y equals, and you could do that if you want, but I would probably just write this. Okay? Great. So let's try a couple more. How about this one? I've got the point 1, 4. I have the point 0, 2. And I have the point negative 1, 0. And my graph looks like this. So what function is that? Well, this is y equals x to the third family. And when I'm thinking about the general form, it's going to be a x minus h cubed plus k. And you can plug in zeros. You can plug in the 0 point here. You know, I don't really care what these letters are, so if you want to use B and C, that's fine with me. If you want to use C and D like we did in the last video, that's fine with me. Whatever works for you. I just need to be able to fill in these places. And I know that CD is the new 0 point. Now, which of these three is my 0 point? That one is. So, write me that equation. Come back when you're done. Okay, welcome back. So I'm plugging in my 0 point, x minus, this is the 0 point, there's the x value, there's the y value, so minus 0 cubed plus 2. I can probably tidy this comfortably to x to the third plus 2. And I still have this a here. What am I supposed to do with that a? Well, I need to plug in another point, not the same point, one of these other points. I'm going to plug in 1, 4. So 4 equals a, 1 to the third plus 2. So 4 equals a plus 2, a equals 2. We're not done yet though, right? We still have to plug this value back in with our 0 point. And so we're going to have 2x cubed plus 2. And certainly you can write that as 2x cubed plus 2. And if you prefer to preserve the transformations, x minus 0 cubed plus 2. Any of these are fine, okay? So, how about this one? This is 1, 1. This is 0, 0. And this is 2, 0. Which I guess means that this is the x-axis, and this is the y-axis. Okay. So, why don't you write the equation for this function? Come back when you're done. Were you able to see that this was an absolute value function, and so your general form might be y equals a absolute x minus h plus k? All right, where's the 0 point here? Well, I remember with regular absolute value, the 0 point is on the vertex. That's the 0 point. Where is it now? It's at 1, 1. So I need to replace h and k with 1 and 1. Now, how do I go about finding a? That's right, I have to plug in one of these other ordered pairs. I've already used this ordered pair, so I have to plug in one of these. I'm going to plug in that one. So I get 0 equals a absolute 2 minus 1 plus 1. I'll subtract 1 from both sides. 2 minus 1 is 1. The absolute value of 1 is 1. 1 times a is a. So because I subtracted this 1 from both sides, I know that a equals negative 1. So we're done then when we say, lots of 1s here, huh? That is my equation for that absolute value function. How about this one? Negative 7, negative 1, negative 4, negative 2, negative 1, negative 1. Oops. Negative 4, negative 2, negative 7, negative 1, negative 1, negative 1. So this is the graph that I'm looking at. And that's what I want you to write the equation for. Give it a try. Okay, so this one is absolute value. So I write down the general form. I identify the 0 point and plug that in for h and k. So notice my h was negative 4, my k was negative 2. I think cleaning that up might be helpful on my brain. To be x plus 4, positive times negative is minus 2. We still need to go back and plug in another ordered pair, this or this, to help us find a. So negative 1 equals a absolute negative 7 plus 4 minus 2. How will we solve for a? Well, I need to add that 2 to both sides of the equation. I also need to combine these like terms. And so I'm going to have negative 1 equals a absolute value of negative 3 minus 2. If I add 2 to both sides, I get 1 equals 3a. So a equals 1/3. Am I done? Not yet. I have to write the equation. Y equals 1/3 absolute x plus 4 minus 2. I see the graph was shifted right 4 and down 2. That's what makes that point. That used to be at 0, 0. But it's a long way to the next point because I squished the graph vertically, which is why we have that. Okay? Let's do one or two more, and then we'll move on to a different type of transformational graphing. Okay. How about 2, negative 3, 3, negative 2, 6, negative 1. So what's this look like? Well, on my graph, 2, negative 3, 3, negative 2, 6, negative 1. This is what I'm looking at. What family of curves is this? If you don't know, you really need to review your reference graphs a lot more. Okay? So take a moment to write the equation for this one. Excellent. So I agree. This is square root. So I'm going to use that general square root equation. And what else do I know? This time, this is my 0 point, not this point. This point on y equals square root of x is at 0, 0. So there's my h, and there's my k. Y equals a square root x minus 2 plus a negative 3. So we're almost done. We still need to plug in another point, either this one or this one, to help us solve for a. So what about negative 1 equals a square root of 6 minus 2? Positive times negative is minus 3. Well, 6 minus 2 is going to be square root of 4, and the square root of 4 is 2 times a. Please don't turn this into negative 1a. Please don't turn this into 5a. I can't combine these because there's no a over here. I can add 3 to both sides and get 2 equals 2a. So I know a equals 1. So y equals 1 times square root x minus 2 minus 3. Or you could leave that 1 out. And there's our equation. Okay, how about one last one? What about this one? Put our three points on it. I would like, where are they? I would like for 12 and 2, 4 and 0, negative 4. I think that'll work for us. Okay, so give this one a try. Is this family, by the way, y equals x to the third or y equals cube root of x? What do you think? So this is y equals cube root of x. Y equals a cube root of x minus h plus k. Now, where's the 0 point on cube root? Well, square root, it's that point. But with cube root, and so many of our functions, this point is normally at 0, 0. Think about that reference graph for a second. Here's our cube root reference graph with negative 1, negative 1, 0, 0, and 1, 1. I want to take that 0 point, which is the middle point, and plug it in for h and k. So y equals a cube root x minus 2 plus 4. We still need to solve for a, so let's plug in another ordered pair. I'm going to plug in this ordered pair. 12 equals a cube root of 4 minus 2 plus 4. Okay, that's a little troubling. And this isn't a to the third. This is a times cube root of. So I'm going to have 12 equals a cube root of 2 plus 4. I'll subtract 4 from both sides. And now I have to divide both sides by cube root of 2. That's an icky a, huh? So let's talk about rationalizing that for a minute. I have cube root of 2. It takes 3 of a kind to get a 2 out from that radical, so I need to multiply by 2 more 2's. And so I'll have 8 cube root of 4 over 2, and I can cancel here and get 4 cube root of 4. All right, so that's a funky a value. What's my equation going to be then? Well, let's put it here at the top of the board. It's going to be y equals 4 cube root of 4 x, oops. That's my a value. Kind of want to push this back in there. X minus 2, and don't forget plus 4. So, oh, and that's a cube root. So yeah, you won't see anything this perilous on any tests we have. And yeah, I probably would clean that up a bit more, i.e. this is a cube root and this is a cube root, so I can just distribute. And so I'll have y equals 4 cube root 4x minus 8, and then the plus 4 on the outside. That's probably the way I would write this, but I would certainly accept that. But more likely, I wouldn't give you something like that. Were this an honors pre-cal class? Oh, sure, why not? We do that. So, you need to be able to go backwards with our reference graphs, and you definitely need to be able to go forwards with our writing transformations of our reference graphs. Let's take, though, transformations and think about applying them to any old f of x, not simply an f of x that is one of our reference functions. So I'm going to give you a graph that we're going to use for all of these problems. I've got negative 1, 2, I've got 1, 4, and I've got 5, negative 1 over here. These are the reference points for this function, f of x. Now, it kind of looks like absolute value, but it's not absolute value, okay? And in fact, to make it a little more exciting, we could come back up here and say this is 7, 0, okay? So these are my points, and what I want to do, we're thinking about this as the reference graph. This is our basic f of x. And now I want to imagine graphing g of x, which is 3 times f of 1/2 x plus 1. I see 3 transformations here, 2 x transformations and 1 y transformation. And what am I applying it to? I'm applying those transformations to these points. So I'm going to write out my reference points, just like I would do with all the other transformational graphing problems. And now I'll start applying my transformations. So I see I'm supposed to multiply all the y's by 3, and inside the function, I've got a plus 1, which means I need to subtract 1 from the x's, and I have a divide by 2, which means I'm going to multiply all the x's by 2. So let's start this process by multiplying the y's by 3 everywhere, and subtracting 1 from the x's. This gives me negative 2, 6, 0, 12, 4, negative 3, 6, 0. I still have to come back and do this transformation. This is the same as x over 2. So I could say, hey, I'm going to divide all of these by 1/2, or I could say, oh, look, I'm dividing. I better multiply all my x's by 2. And so my final points are -4, 6, 0, 12, 8, -3, and 12, 0. It's interesting that these points ended up as flips of each other because they're not here. Okay, so what does this graph look like? Well, it's going to be that shape passing through these points. This is my left endpoint, this is my right endpoint, this is where my high point is, this is where my low point is. So let's graph it. We have -4, 6. We have 0, 12, which means there's the y-axis. We have 12, 0, which means this is the x-axis. And we have 8, -3. Now, I like drawing the curve and then labeling the points, but, we could always go old school here. It's just so tedious to make all these hash marks. 6, 7, 8, 9, 10, 11, 12. Okay, so we've got 12, 0 as one of our points. We have 8, -3. We've got 0, 12. That's this point. And we've got -4, 6. Don't forget to label the ordered pairs on the graph. All right, so that's how we go about doing these transformations. So let me ask you then to try a couple. And we're going to use the same f of x for each of these problems. Our f of x passes through 7, 0, 5, -1, 1, 4, and -1, 2. This is our f of x. And will you please graph g of x, which is 2f of 3x minus 1 plus 4. Okay? Give it a try. Come back when you're done or you need some help. So if I start off with my reference points here, I see I've got 4 transformations, 2 x transformations, 2 y transformations. Remember, we do y transformations following PEMDAS, so I'm going to multiply all the y's 2 before I add 4 to the y's. This stretches the graph vertically, this moves the graph up 4, but I see these 2 x transformations, and I have to follow SADMEP when I carry these out, which means I have to add 1 to the x's and divide the x's by 3. So let's start with adding 1 to all the x's and multiplying all the y's by 2. So my new points, or my transitional points, will be 0, 4, 2, 8, 6, -2, 8, 0. We still have to come back and do the other transformations. I need to divide the x's by 3. And my last y transformation is add 4 to all the y's. And so the points that I'm actually going to graph are 0, 8, 2/3, 12, 2, 2, and 8/3, 4. Okay, so, this is what I want to do. Oh no, I'm not going to do that because I'll forget what points we're using. But I kind of just want to relabel this picture. Um, let's see what I can do. 0, 8, 2/3, 12, 2, 2, and 8/3, which is 2 and 2/3, 4. All right, and then we connect the dots. And so this is a graph of g of x. G of x is a transformed f of x. If I move f of x right 1 and horizontally squish it by a factor of 3, if I vertically stretch it by a factor of 2 and shove the graph up 4 places, I get this picture. Okay, let's do 1 or 2 more of those. How about, and again, we're using the same f of x, 7, 0, 5, -1, 1, 4, and -1, 2. This is our graph of f of x, and I'm asking you to consider graphing g of x equals -2 f of 1/3 x plus 1 plus 4. Okay. Give it a try. See how it goes. Remember, this is 5, -1 over here. Okay, so I'm going to start with those reference points, -1, 2, 1, 4, 5, -1, 7, 0. And I'm going to apply my transformations. I'm going to multiply all the y's by -2 before I add 4 to them. I'm going to subtract 1 from the x's before I multiply the x's by 3. So subtract 1 from all the x's and multiply all the y's by -2. Remember that negative is going to have the effect of flipping this graph upside down. So this will become my low point and this will become my high point. So what points do we have now? We've got -2, -4. We have 0, -8. We have 4, 2. We have 6, 0. I still need to do my second round of transformations. I need to multiply the x's by 3. And I need to add 4 to all the y's. And so I end up with -6, 0, 0, -4, 12, 6, and 18, 4. Okay, so what's that going to look like? -6, 0, 0, -4, 12, 6, and 18, 4. And remember, we needed something that was this flipped upside down. So this high point became this low point, and this low point became this high point. Remember, we had a whole bunch of transformations. We shifted the graph left 1 and horizontally stretched it by a factor of 3. We flipped the graph over the x-axis and vertically stretched it by a factor of 2. And then we added 4 to all the y's, which shifted the graph up 4 places. So, do you think you can do it? Is it feeling comfortable? Are you ready for a quiz to go in the gradebook about this? Because we're getting close to a CFA on that. So, get comfortable with your reference graphs and the reference points and the shapes, and get comfortable with how to do these transformations. And you should also be working on being comfortable with the going backwards problems. where I give you a graph and I ask you to write the equation. I hope this video was helpful, and I'll see you in the next one. Take care.